Alright, so again, still just practicing the antiderivative using the substitution rule. Again, with some more challenging cases. Right, so I've got my x cubed times e raised to the 4x with respect to x. And so again, there's three functions here. There's the x cubed times e, which is raised to the function x to the 4th. So x to the 4th is inside the e function, and so that's what I need to let u equal. So u equals x to the 4th. My du over dx is going to be 4x cubed dx, which if I rewrite this, I have an extra 4 out front, which means I can't just ignore it. It's a part of the problem. So what I do is, well, I've got to move it over here with the du. To do that, well, I divide by 4. And so I'm going to get 1/4, or divide by 4 is fine too, du equals x cubed dx. And so this is what I'm going to substitute out. So I'm going to replace the x to the 4th with u. I'm going to replace the x cubed with a 1/4 times du. And so when I do my substitutions, I get e raised to the u. I don't just replace that with du, I still have a constant 1/4. So there's a 1/4 du. And again, I usually write my constant out front because it's just more proper to do that, but that's just a personal preference. Alright, so now this is the integral I can take the antiderivative of, right? 1/4 e to the u. Well, the antiderivative of that, the 1/4 comes along. The e to the u is just e to the u plus some constant, and then replace u with my original expression, which would have been x to the 4th. So 1/4 e raised to the x to the 4th plus c is my final answer. Alright, next example. Alright, so I've got the 4th root of 1 minus x squared times 5x dx. Alright, so again, there's a whole lot going on here. I've got a 4th root, I've got the inside function, I've got the 5x dx. And so, again, this is inside the 4th root, so that's what u is going to be. U is going to be 1 minus x to the 2nd. Its derivative, negative 2x, move dx to the other side, negative 2x dx. Alright, well, I've got a 5x dx, and so in this case, I think it's easier to use that method that I showed you earlier. Solve this for dx. So if I solve for dx, well, I'm going to divide by my negative 2x. So I'm going to get du divide by negative 2x equals dx. That's what I'm going to substitute out. Alright, so I'm going to do my substitution. Now, when I do my substitution, I am also going to rewrite my 4th degree function as the fraction 1/4, right? 4th root is the fraction 1/4. Replace this inside with u, so that gets replaced with u. I still have a 5x because I didn't do anything with the 5x because all I'm replacing is the dx, right? Dx is getting replaced with du over negative 2x. So du divided by negative 2x. Simplify. In this case, it doesn't simplify really nice. I'm left with a fraction. So the x's, again, the goal is to remember to get rid of all of the x terms. And I do that. This works. The x cancels with the x, but I'm still left with a 5 divided by negative 2. Right? And I'm left with a fraction. Fine. It's a fraction. It's just a number. It's just going to come along when I take the antiderivative. Alright, so I get negative 5 halves, u raised to the positive 1/4 power du. Now I can take my general antiderivative, which is my negative 5 halves comes along. Power rule is I add 1, so I get 1/4 plus 1, which will give me 5/4. Remember, you don't divide by 5/4. You rewrite it as multiplied by the reciprocal. So I'm going to multiply by 4/5. And then there's the constant I don't want to forget. And I put x instead of u here. Alright, last step is to replace my terms with x, and I'm going to go ahead and simplify. This actually simplifies nice. Even though I started out with ugly fractions, it actually simplifies nice, and I'm remembering what u is. Alright, first of all, the 5 reduces with the 5. Leaves me with negative 1, right? I got negative on the 5. The 2 reduces into the 4, leaves me with 2, so I'm left with a negative 2. So I get negative 2 out front. instead of u, and I've already forgot what u was, 1 minus x squared. 1 minus x squared raised to the 5 fourths power plus some constant. And there is my final answer. Right, there is the general antiderivative of that original expression. All right, the last thing I'm going to do is I'm going to do an example where it's, so far I've just been doing the general antiderivative, all possible antiderivatives, the indefinite integral. I haven't done an example of the definite integral yet. The definite integral just means, again, the last step would be, instead of having this plus c, well, you take your, remember, the fundamental theorem of calculus is a, b, f of x, little lowercase f of x, is the general antiderivative, and then I've placed my a and my b in. Excuse me. So it's the same thing. I'll just have an additional step at the end where I do this. So I'm going to start off with, I'm going to rewrite it. 0 to 3, x minus 6 squared dx. And there is a different way to do this where you replace everything. But I think it's easier just to get back to the general antiderivative of f of x and then plug your lower and upper values in. So there is an alternative method to this. This is, again, the method that I prefer. You can use either method. I don't care. But this is the method I think that's easiest. All right, so first of all, I do my u substitution. I get rid of... So first thing I do is find my antiderivative with respect to u, and then I go back to my antiderivative with respect to x. All right, so replace the inside function with u. Well, the inside function is x minus 6 is inside the square function. The derivative of that is 1. All right, so in this case, it's a simple case. du replaced with dx. So, again, I'm going to substitute that out with u. I'm going to substitute that out with du. So, 0 to 3, u squared du. My general antiderivative would, again, I'm just finding f of u right now. Which would be, in this case, u cubed divided by 3. But I can't plug my 0 and my 3 yet. 0 and 3, remember, are x terms, right? This is an x term, this is an x term. And so I have to go back to the f sub x in order to plug my 0 and my 3 in. And so before I can plug my 0 and my 3 in, I've got to go back and replace it with the x minus 6. And so this really is x minus 6 cubed divide by 3 from 0 to 3. Now, I can find f of 3 minus f of 0. I can only do that, though, if these were x terms. Now, there's an alternate ways where you can rewrite these as u terms, and then you don't have to do that substitution back. But I actually think it's easier just to keep it simple, just to replace it always as x terms. All right, so this is the expression I get. I get my f of x, which is x minus 6 divided by 3, plug in my 0 and my 3 into my general antiderivative, and I forgot my cube. And so I'm going to get 3 minus 6 cubed divided by 3, and then 0 minus 6 cubed divided by 3, and then you simplify those expressions, which gives you negative 9 minus a negative 72, not 3, 72. And so that's actually a plus. And so 63 is my final answer, which you could check on the graphing calculator. All right, so I'm going to stop there. That's the substitution rule, all right, which again is one of the harder rules. So do make sure you practice it, and we will stop there.